Kubernetes Certification, Real-World Project Introduction. A Kubernetes certification real-world project is a practical cloud-native project designed to help you prepare for Kubernetes certifications like CKA and CKAD while building something useful for your portfolio. Kubernetes is an open-source system for automating deployment, scaling, and management of containerized applications. Kubernetes certification preparation often focuses on kubectl commands, CR pods, deployments, services, config-maps, secrets, probes, volumes, ingress, RBAC, network policies, troubleshooting, scaling, security, application deployment. A common learning topic is, what real-world Kubernetes project should I build for certification preparation? This guide explains: copy tech certification-focused project idea, copy real-world architecture, Kubernetes manifests, Spring Boot deployment, PostgreSQL deployment, ConfigMap, secret, service, ingress, probes, autoscaling, RBAC, network policy, troubleshooting, monitoring, exam practice tasks, interview questions. The CKA exam is an online, proctored, performance-based exam where candidates solve tasks from the command line in a Kubernetes environment. And the Linux Foundation page currently lists the exam duration as 2 hours and based on Kubernetes v1.34. Simple definition. A Kubernetes certification real-world project means building and deploying a real application on Kubernetes while practicing exam-style tasks. Simple project. React frontend, Spring Boot backend, PostgreSQL database, Kubernetes deployment, Ingress, plus service, plus config-map, plus secret. Main goal: learn Kubernetes by deploying a real app, not only reading theory. Why build a real-world project? Certification preparation can become too command-focused. A real-world project helps you understand CKAD, why deployments exist; CKAD, why services are needed; CKAD, why config maps and secrets matter; CKAD, why probes are important; CKAD, why ingress is used; CKAD, how troubleshooting works; CKAD, how apps behave during rollout; CKAD, how scaling works; CKAD, how security is applied. Example: reading about readiness probe is good. Breaking a readiness probe and fixing it is much better. Certification target. This project helps with check CKAD, check CKA, Kubernetes interview preparation, DevOps beginner preparation, cloud-native backend deployment, Spring Boot production deployment. CKAD focuses on designing, building, and deploying cloud-native applications for Kubernetes, and it is also a performance-based online exam. CKA is more administration-focused. CKAD is more application developer-focused. CKA versus CKAD, certification main focus. CKA, cluster administration. CKAD, application deployment. CKS, Kubernetes security. For backend developers, start with CKAD if your goal is application deployment. Choose CKA if your goal is cluster operations admin. Project name: Cloud Native Order Management Platform. Project: Kubernetes Order Management System. Services: frontend service, order service, inventory service, notification service, Postgres, Redis. Kubernetes objects: code, namespace, deployment, service, ConfigMap, secret, persistent volume claim, ingress, horizontal pod autoscaler, service account, role binding, network policy, real-world architecture, user browser, ingress controller, front-end service, front-end service, PostgreSQL service, Redis service, expanded architecture, React front-end, task, Spring Boot order API, PostgreSQL, Redis cache, Kubernetes, monitoring and logs, certification skill mapping, Kubernetes skill, project task pods, run single test pod, deployments, deploy Spring Boot API services, expose backend internally, config maps, externalize app config, secret store DB password, volumes, persist PostgreSQL data, Ingress, expose app by hostname path probes, health checks, HPA, autoscale backend, RBAC, service account permissions, network policy, restrict traffic, troubleshooting, fix broken pods, services. A deployment manages a set of pods for an application workload and provides declarative updates for pods and replica sets. Step 1. Create namespace. Namespace. API version v1. Kind namespace. Metadata name order platform. Apply. kubectl apply -f -namespace.yaml. Check. kubectl get ns. Y namespace. Check. Isolate project resources. Check. Organize workloads. Check. Easier cleanup. Check. Exam practice. Step 2. Create Spring Boot Docker image. Spring Boot Docker file. From Eclipse Tamarin 21JRay. Work dir /app. Copy target order service.jar app.jar. Expose 8080. Entry point. Java -jar app.jar. Build. Docker build -t order service 1.0.0. For local Kubernetes. Minikube image load order service 1.0.0. Or kind load Docker image order service 1.0.0. Step 3. Create ConfigMap. ConfigMap stores non-sensitive configuration. API version v1. Kind ConfigMap. Metadata. Name order service config. Namespace order platform. Data Spring profiles active. K8s. Server port 8080. DB host Postgres service. DB port 5432. DB name orders DB. Apply. kubectl apply -f configmap.yaml. Check. kubectl get configmap -n order platform. kubectl describe configmap order service config -n order platform. Step 4. Create secret. Secret stores sensitive values. API version v1. Kind secret. Metadata. Name Postgres secret. Namespace order platform. Type opaque. String data. Postgres user. Orders user. Postgres password. Change me. Apply. kubectl apply -f secret.yaml. Check. kubectl get secret n order platform. kubectl describe secret Postgres secret n order platform. Important. Do not commit real production passwords to Git. Use secret managers in real production. Step 5. Deploy PostgreSQL. PostgreSQL deployment. API version apps/v1. Kind deployment. Metadata. Name Postgres. Namespace order platform. Spec. Replicas 1. Selector. Match labels app. Postgres. Template. Metadata. Labels app. Postgres. Spec. Containers. Name Postgres image. Postgres 16. Ports. Container port 5432. Env. PostgresDB. Value from ConfigMap keyref. Name. Order service config. Key DB name. Postgres user. Value from secret keyref. Postgres secret. Key Postgres user. Name. Postgres password. Value from secret keyref. Name. Postgres secret. Key Postgres password. Apply. kubectl apply -f postgres deployment.yaml. Check. kubectl get pods n order platform. kubectl logs deployment Postgres n order platform. Step 6. Create PostgreSQL service. Service. API version v1. Kind service. Metadata. Name Postgres service. Namespace order platform. Spec. Selector. App Postgres. Port 5432. Target port 5432. Apply. kubectl apply -f postgres service.yaml. Check. kubectl get svc -n order platform. Y service. Pods can restart and get new IPs. Service gives stable DNS name. Inside cluster. Postgres service.order platform svc.cluster.local. Step 7. Add persistent volume claim. For real-world PostgreSQL, use persistent storage. PVC. API version v1, kind, persistent volume claim, metadata, name, Postgres PVC, namespace, order platform, spec, access modes, read-write once, resources, requests, storage, 2 GB. Mount in PostgreSQL deployment. Volume mounts, name, Postgres storage, mount path, var lib, PostgreSQL data. Volumes, name, Postgres storage, persistent volume claim name, Postgres PVC, YPVC, comma, data survives pod restart. Real-world database behavior, certification volume practice. Step 8. Deploy Spring Boot order service. Deployment. API version, apps v1, kind deployment, metadata, name, order service, namespace, order platform, spec, replicas, 2, selector, match labels, app, order service, template, metadata, labels, app, order service, spec, containers, name, order service, image, order service 1.0.0, image pull policy, if not present, ports 8080 and from, name, ConfigMap ref, name, order service config, name, DB username, value from, secret key ref, name, Postgres secret, key, Postgres user, name, DB password, value from, secret key ref, name, Postgres secret, key, Postgres password. Apply. kubectl apply-f, order service deployment.yaml. Check. kubectl get deployment-n order platform, kubectl get pods-n order platform, kubectl logs deployment order service-n order platform. Step 9. Create order service, API version v1, kind service, metadata name order service namespace order platform, spec selector app order service, ports, port 8080 target port, 8080. Apply. kubectl apply, -f order service.yaml. Test inside cluster. kubectl run curl test, -image, curl images curl, n order platform, -rm, it, sh. Then curl http, order service 8080, actuator health. Step 10. Add readiness and liveness probes. Spring Boot actuator endpoints. Actuator-health.readiness, actuator-health.liveness. Kubernetes probes. Readiness probe, HTTP GET, pass actuator health readiness, port 8080, initial delay seconds, 20, period seconds, 10. Liveness probe, HTTP GET, path actuator health liveness, port 8080, initial delay seconds, 60, period seconds, 20. Y probes. Kubernetes knows when pod is ready. Kubernetes unhealthy pods can restart. Kubernetes safer deployments. Kubernetes real production behavior. Kubernetes supports liveness, readiness, and startup probes to know when containers are alive, ready for traffic, or successfully started. Step 11. Expose app with Ingress. Ingress. API version, networking.k8s.io/v1. Kind Ingress. Metadata, name order platform Ingress. Namespace, order platform. Spec, rules, host order local. HTTP, path/API, path type prefix. Backend, service. Name order service. Port, number 8080. Apply. kubectl apply-f, ingress.yaml. Ingress lets you expose HTTPS services using hostnames, paths, and routing rules through the Kubernetes API. For local testing, Minikube add-ons enable Ingress. Add hosts entry. 127.0.0.1 order.local. Step 12. Add frontend deployment. Frontend deployment. API version. Apps v1. Kind deployment. Metadata. Name frontend. Namespace order platform. Spec. Replicas 2. Selector. Match labels. App frontend. Template. Metadata. Labels. App frontend. Spec. Containers. Name frontend. Image. Order frontend. 1.0.0. Image pull policy, if not present. Frontend service. API version v1. Kind. Service. Metadata. name, front-end service, namespace, order platform, spec, selector, app, front-end, ports, 80, target port, 80, ingress route, path, path type, prefix, backend service, name, front-end service port, number, 80. Step 13. Add resource requests and limits. Add to container. Resources, requests, CPU, 250M, memory, 512MI, limits, CPU, 500M, memory, 1GI. Why? Check. Prevents one pod from consuming all resources. Check. Helps scheduler place pods. Check. Supports autoscaling. Check. Real-world production practice. Step 14. Add horizontal pod autoscaler. HPA. API version, autoscaling v2. Kind, horizontal pod autoscaler. Metadata. Name, order service HPA. Namespace, order platform. Spec, scale target ref. API version, app/v1. Kind, deployment. Name, order service. Min replicas, 2. Max replicas, 5. Metrics, type, resource. Name CPU, target. Type, utilization, average utilization. Apply. kubectl, apply, -f, hpa.yaml. Check. kubectl get HPA, Nash N order platform. kubectl describe HPA, order service HPA, Nash N order platform. Kubernetes supports horizontal pod autoscaler with kubectl get HPA, kubectl describe HPA, and kubectl delete HPA. Step 15. Add service account. Service account. API version v1. Kind, service account, metadata. Name, order service SA. Namespace, order platform. Use in deployment. Service account name, order service SA. Why? Identity for pod, RBAC practice, least privilege security, certification practice. Step 16. Add RBAC. Role. API version. RBAC.authorization.k8s.io/v1. Kind. Role service read config. Namespace, order platform. API groups, ConfigMaps, verbs, get, list, role binding. API version RBAC.authorization.k8s.io/v1. Kind role binding. Metadata name order service read config binding. Namespace order platform. Subjects. Kind service account. Name order service SA. Namespace order platform role ref. Kind role name. Order service read config. API group. RBAC.authorization.k8s.io. Kubernetes RBAC uses roles, cluster roles, and role bindings, cluster role bindings to control API access. Default RBAC policies grant no broad permissions to ordinary service accounts outside kube system. Step 17. Add network policy. Network policy example. API version, networking.k8s.io/v1 kind network policy. Metadata. Name allow order to Postgres. Namespace order platform. Spec pod selector match labels. App Postgres. Ingress from pod selector match labels. App order service. Ports protocol TCP port 5432. Meaning, only order service pods can access Postgres on port 5432. Network policies specify how pods are allowed to communicate with network entities. Step 18. Add rolling update practice. Update image. kubectl set image deployment order service. Order service equals order service 1.0.1. N order platform. Check rollout. kubectl rollout status deployment order service. N order platform. View history. kubectl rollout history deployment order service -n order platform. Rollback. kubectl rollout undo deployment order service -n order platform. Certification practice. Update app. Check rollout. Break app. Rollback app. Step 19. Add troubleshooting practice. Break image name. Image. Order service wrong tag. Then check. kubectl get pods -n order platform. kubectl describe pod podname -n order platform. kubectl logs podname -n order platform. Common errors. Error meaning image pull back off. Image cannot be pulled. Crash loop back off. App starts and crashes repeatedly. Pending pod cannot be scheduled. Error image pull. Image pull failed. Create container config error. Config secret missing. Kubernetes debugging docs recommend triaging whether the issue is with pods, controllers, or services, and using tools like logs and describe to diagnose application problems. Step 20. Debug service connectivity. Commands. kubectl get svc n order platform. kubectl get endpoints n order platform. kubectl describe svc order service n order platform. Common problem. Service selector does not match pod labels. Example. Selector, app, order, service. Pod label must match. Labels, app, order service. Step 21. Debug ConfigMap and secret. Check env. kubectl exec -it -podname -n order platform -env. Check ConfigMap. kubectl describe ConfigMap order service config -n order platform. Check secret exists. kubectl get secret Postgres secret Mattis n order platform. Common problem. Secret key name does not match env reference. Step 22. Debug Ingress. Commands. kubectl get Ingress n order platform. kubectl describe Ingress order platform Ingress n order platform. kubectl get svc n order platform. Common issues. Check Ingress controller missing. Check wrong host, wrong path, wrong service name, wrong service port. App not ready. Step 23. Add monitoring basics. Useful commands. kubectl top pods n order platform. kubectl top nodes. Logs. kubectl logs deployment order service n order platform. kubectl logs deployment order service n order platform #tail 100. Events. kubectl get events -n order platform -sort by.metadata.creation timestamp. Kubernetes documentation has a monitoring, logging, and debugging section for gathering relevant information and resolving application and cluster issues. Step 24. Add Helm as optional upgrade. Helm chart structure. Order platform chart. Chart.yaml. Values.yaml. Templates. Deployment.yaml. Service.yaml. ConfigMap.yaml. Secret.yaml. Use Helm after you understand raw YAML. Commands. Helm install order platform. Order platform chart. Helm upgrade order platform. Order platform chart. Helm rollback order platform 1. For certification, CKA CKAD mostly focuses on kubectl and Kubernetes objects. Helm is useful for real-world deployment. But first, master raw manifests. Step 25. Add CI/CD optional upgrade. Pipeline. Code push. Down build Spring Boot jar. Down build Docker image. Down push image. Down update Kubernetes deployment. Down check rollout. GitHub Actions concept. Name. Deploy to Kubernetes. Run. kubectl set image deployment order service. Order service is ghcr.io company order service gethub.sha. N order platform. kubectl rollout status deployment order service. N order platform. Real world project structure. Kubernetes cert project. N backend. SRC, frontend. Y, Dockerfile. Y, SRC, KDeets, namespace YAML, ConfigMap YAML, secret YAML, Postgres deployment YAML, Postgres service YAML, Postgres PVC YAML, order deployment YAML, order service YAML, frontend deployment YAML, frontend service YAML, Ingress YAML, 1, HPA YAML, 2, RBAC YAML, and NetworkPolicy YAML. ND, real-world app features. Backend features. Create order. Get order by ID. List orders. Update order status. Health endpoint, database connection, readiness, liveness, front-end features. Order list. Create order form. Order details, API integration. Database. Const PostgreSQL orders table. Const persistent storage. Kubernetes. Click deploy app. Click expose app. Configure app. Secure app. Scale app. Troubleshoot app. Certification practice tasks. Task 1. Create namespace. Create namespace order platform. Deploy all resources inside it. Command. kubectl. Create namespace order platform. Task 2. Create deployment. Create deployment order service with 2 replicas using image order service 1.0.0. Command style. kubectl. Create deployment order service minus image order service 1.0.0 minus replicas equals 2 minus n order platform. Task 3. Expose deployment. kubectl expose deployment order service minus port 8080 minus target port 8080 minus n order platform. Task 4. Create ConfigMap. kubectl create ConfigMap order service config dash from literal Spring Profiles Active K8s dash from literal DB host Postgres service dash n order platform. Task 5. Create secret kubectl create secret generic Postgres secret dash from literal Postgres user orders user dash from literal Postgres password change me dash n order platform. Task 6. Scale deployment. Deployment order service / replicas equals 4 / n order platform. Task 7. Update image. kubectl set image deployment order service. Order service equals order service.1.0.1 / n order platform. Task 8. Rollback deployment. kubectl rollout undo deployment order service. None order platform. Task 9. Debug crash loop backoff. Commands. kubectl get pods n order platform. kubectl describe pod name n order platform. kubectl logs pod name n order platform. kubectl logs pod name previous n order platform. Task 10. Debug service. Commands. kubectl get svc nen order platform. kubectl get endpoints nen order platform. kubectl describe svc order service nen order platform. CKA focused practice. Practice. COX. Nodes, pods, kubelet issues, cluster troubleshooting, RBAC, networking, storage, upgrades, etcd backup restore. Example tasks. Find why node is not ready. Create RBAC role. Troubleshoot service networking. Create PVC. Drain node safely. CKAD focused practice. Practice. Pods, deployments, services, config maps, secrets, probes, jobs, cron jobs, resource limits, security context, init containers, multi-container pods. Example tasks. Deploy app with n variables, add readiness probe, create config map and mount it. Run job, fix failing deployment. Common beginner mistakes. 1. Only reading theory, bad. Read Kubernetes docs only, better. Deploy, break, debug, fix. 2. Not practicing kubectl. Certification exams are command line heavy. Practice. kubectl get, kubectl describe, kubectl logs, kubectl exec, kubectl apply, kubectl edit, kubectl rollout 3. Forgetting namespace. Bad. kubectl get pods when resources are in another namespace. Better. kubectl get pods -n order platform 4. Wrong service selector. Bad. Selector app. Backend. Pod label. App. Order service. Result. Service has no endpoints. 5. Missing readiness probe. Without readiness probe, traffic may reach app before it is ready. 6. Hard coding secrets. Bad. DB password. Password 123. Better. Use secret or external secret manager. 7. Ignoring resource limits. Without resource limits. Noisy neighbor problem. unstable pods, hard auto-scaling, bad production behavior. Best practices. Practice daily with kubectl, build real app project, use namespaces, use labels carefully, use services for stable networking, use config maps for non-sensitive config, use secrets for sensitive config, add readiness liveness probes, add resource requests and limits, practice rollouts and rollbacks, troubleshoot broken deployments, use network policy for traffic control, use RBAC with least privilege, document every command, create README with architecture, practice under time pressure. Kubernetes certification interview questions. 1. What is Kubernetes? Kubernetes is an open-source platform for automating deployment, scaling, and management of containerized applications. 2. What is a pod? A pod is the smallest deployable unit in Kubernetes. It usually runs one application container, but it can run multiple tightly coupled containers. 3. What is a deployment? A deployment manages application pods and supports declarative updates and rollbacks. 4. What is a service? A service provides stable networking for pods. Pods can restart and change IPs, but service gives a stable endpoint. 5. What is ConfigMap? ConfigMap stores non-sensitive configuration. Example: Spring Profiles Active, K8s, Server Port 8080. 6. What is Secret? Secret stores sensitive configuration like passwords, tokens, and keys. 7. What is Ingress? Ingress manages external HTTP/HTTPS access to services using host path rules. 8. What is Readiness Probe? Readiness Probe tells Kubernetes whether a pod is ready to receive traffic. 9. What is Liveness Probe? Liveness Probe tells Kubernetes whether a container is alive or should be restarted. 10. What is HPA? HPA means Horizontal Pod Autoscaler. It scales pod replicas based on metrics like CPU usage. 11. What is RBAC? RBAC controls who can do what in the Kubernetes API using roles, cluster roles, role bindings, and cluster role bindings. 12. What is network policy? Network policy controls allowed network communication between pods and other network entities. 30-day learning plan, Week 1, Kubernetes Basics. Learn. Cat, pods, deployments, services, namespaces, labels, kubectl basics. Practice. Deploy Spring Boot app with service. Week 2, configuration and storage. Learn. ConfigMap, config secret, config volumes, config end variables, database deployment. Practice. Deploy Spring Boot plus PostgreSQL. Week 3, networking and scaling. Learn. Ingress, network policy, readiness liveness probes, HPA, rollout, rollback. Practice. Expose app and autoscale backend. Week 4, troubleshooting and security. Learn. kubectl logs, kubectl describe, kube events, kube RBAC, kube service account, kube broken deployment debugging, kube exam style speed practice. Practice. Break and fix 20 Kubernetes issues. Final project checklist. Your project should include: check README architecture diagram, check namespace, check Spring Boot deployment, check frontend deployment, check PostgreSQL deployment, check PostgreSQL PVC, check ConfigMap, check secret, check services, Ingress, readiness probe, liveness probe, resource requests limits, HPA, RBAC, network policy, troubleshooting guide, rollout, rollback examples, kubectl command cheat sheet. Portfolio README template project, Kubernetes order management platform. Goal: deploy a full-stack Spring Boot application on Kubernetes. Stack: Spring Boot, React, PostgreSQL, Docker, Kubernetes, Ingress, HPA, RBAC, network policy. Kubernetes objects: namespace, deployment, service, ConfigMap, secret, PVC, Ingress, HPA, role binding, network policy. Certification skills practiced, application deployment, configuration, networking, storage, scaling, security, troubleshooting. Final summary. A Kubernetes certification real-world project helps you prepare for CKA CKAD while building practical cloud-native skills. Important concepts include pods, deployments, services, namespaces, configmaps, secrets, PVC, Ingress, probes, HPA, RBAC, network policy, troubleshooting, rollout, rollback, kubectl commands. Backend developers already understand APIs, Spring Boot, databases, Docker, deployment. This makes Kubernetes easier to learn through real projects. Key idea: build, break, debug, and fix a real Kubernetes application. That is one of the best ways to prepare for Kubernetes certification and real-world cloud-native jobs.